Question over here is alkynes are less reactive than alkenes towards addition of bromine. Alkynes are less reactive than alkenes towards addition of bromine. Why? Okay. See, it is absolutely true that alkenes are more reactive. Alkenes are more reactive. Alkenes are more reactive than alkynes towards electrophilic addition reaction. Towards electrophilic addition reaction, basically. Why this is so? This is because of the formation of highly strained bromonium ion three-membered ring with a double bond. Okay, so this is the bromonium ion which is we are actually going to form when alkynes are being actually reacted with the halogens. Okay, and this is three-membered ring. This is three-membered ring with a double bond present. With a double bond present. So alkynes are less reactive towards electrophilic addition because of the formation of highly strained bridged bromonium ion three-membered ring with a double bond. Okay, moreover, if I talk about alkynes, okay, suppose if I'm taking its ethyne, okay, if I talk about alkynes, the carbon atom in alkynes is highly electronegative. Why? Because it is sp hybridized, more percent s character, because of which it tightly holds the pi electron. Hence we can say that alkynes are less reactive than alkenes towards addition of bromine. And if I just talk about option number A over here, CH double bond CH, and there is a formation of Br positive of bromonium ion through alkyne. It is less stable than CH to CH2, and there is the bromonium ion formed from alkene. So yes, option number A is absolutely right, because it is a three-membered ring with a double bond, so it is less stable. It is highly strained bridge bromonium ion. Option number B, they are saying that this one is more stable than the bromonium ion. Okay, we are actually forming from alkenes. So I'll just say option number B is out of the race. Talking about both are equally stable, original statement is incorrect. Both the options are actually the wrong. It's only option number A which is actually the right answer to this particular question. The question over here is molar volume of carbon dioxide is maximum at. Molar volume we are talking about for carbon dioxide gas. If we are talking about molar volume, that means we'll be applying that ideal gas equation, PV is equals to nRT1. Yeah, yes, of course, yes. So yes, over here we are given with the four options: 0 degrees Celsius and 2 atm. Option number B, STP, standard temperature pressure. Option number C, 273 degrees Celsius and 2 atm. And option number D, 127 degrees Celsius and 1 atm basically. So over here, first of all, I'll convert the degree Celsius into Kelvin. So 0 degrees Celsius, it means it is equals to 273 Kelvin. Talking about STP, so it's actually 273 Kelvin and 1 atm pressure. 1 atm pressure. Okay, talking about option number C, is 273 degrees Celsius, which means it will be equals to 273 plus 273, which will be equals to 546 Kelvin, and 127 degrees Celsius. That means addition of 273, it becomes 400 Kelvin basically. It is actually 400 Kelvin. Okay. Now see, from ideal gas equation, we know that PV is equals to nRT, wherein if we are talking about molar volume, number of moles, I'll take only one. So it is PV is equals to RT basically. Talking about molar volume, Vm, I'm representing the molar volume by Vm. It is equals to RT by P basically. And molar volume is directly proportional to temperature and inversely proportional to pressure. That means when temperature increases, volume increases. Okay. And when pressure increases, volume decreases. In a way, we can say that more is the T by P ratio. More is the T by P value. More is the T by P value Okay, more will be the molar volume. More is the molar volume. Molar volume. Are you getting this thing? Yeah, of course. No issues in it. Okay. So we'll be calculating the T by P values from the given for the given options to us. Talking about option number A, the T by P value of option number A will be it's 273 the temperature in kelvins divided by pressure in atm, which is 2. Okay, so it becomes equals to 2 ones are okay, then 2 threes are 6, fine, then 2 6 are 12 and point 0.5. So T by P value is 136.5 Kelvin per atm. Okay, fine. No issues in it. If I talk about option number B, what's the T by P value? T by P value for option number B is actually 273 divided by 1. It is actually equals to 273 only. Talking about T by P value for option number C, it is equals to 546 divided by 2, which is actually in turn becomes 273 Kelvin. If I talk about T by P value or option number D, it is equals to 400 Kelvin divided by 1. So yeah, we have all the T by P values for the given four options to us. More is the T by P value, more will be the molar volume. So among A, B, C and D, it's option number D which is having the higher T by P value. If it is having the higher T by P value, which means molar volume of carbon dioxide is maximum at 127 degrees Celsius and 1 atm pressure. Option number D is the right answer to this question. Question over here is, what is the order of heat of combustion of the following? It's heptane. It's heptane. So it's CH3, CH2, 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 CH2. So it's 1, 2, 3, 4, 5, 6 and it's CH3. Pentane. It's CH3, CH2, CH2, CH2 and it is CH3. Okay. 1, 2, 3, 4, 5. It's 2-methyl pentane. 2-methyl pentane basically. So it's CH3, CH, then it's CH3, then it's CH2, CH2 and CH3. Okay. It's 2,2-dimethyl butane. Okay. So it's CH3. It's carbon 2,2-dimethyl. Okay. And it's butane 1, 2, CH2 and CH3. Okay. Now if you want to talk about the order of heat of combustion. So what do you mean by heat of combustion? It's the amount of energy released when 1 mole of a given substance undergoes combustion in the presence of oxygen. So more are the number of carbon atoms, more will be the heat of combustion. So we can say heat of combustion is directly proportional to the number of carbon atoms basically. Also, for the same number of carbon atom, if we have in a compound, if we are having two compounds and we are having same number of carbon atoms in both the particular compounds, then heat of combustion is actually what? Tell me. Is inversely proportional to branching. I mean to say heat of combustion decreases with the increase in branching. Okay? Heat of combustion decreases with increase in branching. Why so? Because when branching happens up, what is happening? Surface area get reduced and hence heat of combustion decreases basically. Is it clear? So more are the number of carbon atoms, more will be the heat of combustion. More is the branching, less will be the heat of combustion. Okay. Moreover, for the compounds having same molecular mass, okay, for the compounds having same molecular mass also, having same number of carbon atoms also, we can say one thing, that heat of combustion is basically inversely proportional to the stability of that particular compound. Over here we are having four options: heptane, pentane, 2-methyl pentane, 2,2-dimethyl butane. Heptane is having 7 carbon atoms. So heat of combustion for heptane will be higher, first one. If I talk about pentane having 5 carbon atoms, if I talk about 2-methyl pentane, so let's count the number of carbon atoms. 5 carbon atoms, it's having 1, 2, 3, 4, 5, 6. 6 carbon atoms. If I talk about 2,2-dimethyl butane, it is also having 6 carbon atoms. Okay. Which means that pentane will be having the least heat of combustion. So it will be the least one. Among third and fourth, we are seeing that in third 2-methyl pentane there is only one branching, whereas if I talk about fourth 2-dimethyl butane there are two branching. Branching increases, heat of combustion decreases. So among third and fourth, it is the third one which will be having the high heat of combustion. Then comes the fourth one, and the last one will be the second. This is the order of heat of combustion for the following given question to us. So it's 1/3, 4th, 2nd. 1/3, 4th, 2nd. 1/3, 4th, 2nd. Option number C is the right answer to this question. Question over here is, which of the following is a non-aromatic compound? Okay. So first of all, we'll discuss the criteria uh, to be followed for a compound to be aromatic in nature. So basically, for a compound to be aromatic in nature, it should follow Huckel's rule. That means there should be the presence of 4n plus 2 pi electrons, delocalized electrons present in the ring, following 4n plus 2 pi electron rule basically. It's the Huckel's rule. Secondly, the compound should be cyclic in nature. It should be planar. There should be conjugation taking place. Okay. If I look for option number A, this particular compound is cyclic. It is planar in nature. Absolutely right. No doubt in this. Okay. But is the conjugation taking place? Is there alternate double bond and single bond present in this particular compound? No conjugation is taking place. There is no conjugation. Conjugation is not taking place. Okay. Fine. That means delocalization of pi electrons are not taking place basically in this ring. If I talk about Huckel's rule, there are presence of 4 pi electrons. There are presence of 4 pi electrons which are actually not participating in conjugation. So it is actually violating these two particular rules. So we'll say that it is non-aromatic compound. It is non-aromatic compound. If I talk about option number B over here, option number B, fine. So this is cyclic. Okay, each and every carbon atom is sp2 hybridized, so it is planar. Conjugation is taking place. Yes, conjugation is taking place. You can just have a look. The conjugation is actually taking place. Fine, the conjugation is taking place. How many pi electrons are involved in delocalization? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 pi electrons delocalizing basically in the rings. So yeah, if it is 4n plus 2 equals to 10, 4n is equals to 8, n is equals to 8 by 4, which is equals to 2. So yes, the value of n actually ranges from 0, 1, 2, 3 and so on. So it is aromatic compound. This is actually aromatic compound. Talking about C, this is cyclic, this is planar. Over here conjugation is taking place. But how many electrons are involved? How many pi electrons are delocalizing? It's only 4 pi electrons, not following Huckel's rule, but conjugation is taking place. It is not following Huckel's rule, but there is conjugation which is taking place. So it is anti-aromatic compound. It is anti-aromatic compound basically. If I talk about option number D, over here we have lone pair of electrons present on the oxygen atom which are involved in delocalization of the ring basically. Over here delocalization of electrons is taking place, conjugation is taking place, cyclic ring, sp2 hybridized atoms are present, and moreover there are 6 pi electrons which are actually delocalizing following the Huckel's rule. So it is also aromatic in nature. It is also aromatic in nature. Non-aromatic compound, option number A, the right answer to this question. The question is in front of you and it says that in acidic medium, equivalent weight of K2Cr2O7 is what? Wherein the molecular weight of K2Cr2O7 has been given as capital M. So, if I just talk about the reaction of K2Cr2O7 in acidic medium, so that particular reaction, because there are some common reactions you need to learn for. So over here, if I just talk about the reaction of K2Cr2O7 in acidic medium, this is the particular equation. It is actually K2Cr2O7 plus 14H positive plus 6 electrons gives us twice of K positive plus twice of Cr3 positive plus 7H2O. Are you getting this particular point? Yeah, you should. Absolutely fine. Okay. Now, one thing I can actually talk about, that over here, if I just want to know the equivalent weight, it is equals to the molar mass divided by number of electrons involved in reaction. Number of electrons involved in reaction basically. Absolutely fine. Molar mass have been given to us. We need to find out the number of electrons involved in the reaction. Just seeing this particular reaction, we can say there are 6 number of electrons involved in the reaction. How come? Over here in K2Cr2O7, the oxidation state, or you can say the oxidation number of chromium atom is plus 6. Whereas in product side, the oxidation number of chromium is plus 3. That means there is reduction taking place. Reduction is happening up, which means that two chromium atoms are reduced to, two chromium atoms having plus 6 oxidation state are reduced to what? Plus 3 oxidation state. Reduction is taking place. Gain of electrons is actually happening. One chromium atom having plus 6 oxidation state requires 3 electrons for reduction. So, two chromium atoms having plus 6 oxidation state require 6 electrons to get reduced to Cr3 positive basically. So, there are 6 electrons that are involved in the reaction, in the reduction process which is actually taking place. So, here we are. Hence, I'll say it's m by 6, the equivalent weight of K2Cr2O7. Option number C is the right answer to this question. Over here, the catch is one thing, that you need to know the reaction of K2Cr2O7 in acidic medium. That's what I want to say. Option number C is the right answer for this question.